All right. Red, red, red. I think we're good to go.
Okay.
And you forgot your packet.
Yeah.
That's okay. Because this right here, the high set math section, is basically testing your fundamental skills, otherwise kind of known as like numerical or number literacy, math literacy. Can you do the basic things that would eventually build up to make more complex problems? And they're really just testing the fundamentals.
Yeah.
If you remember last time we did adding and subtracting polynomials. Okay, and did I delete some of those pages? I know we did zeros as well. So we did, here we go. Here's our adding one polynomial, remember, with the smiley faces. Okay, and then did it with the images. That was kind of shaky, but ended up hopefully making somewhat sense. And then we did these problems, the zeros by factoring. How did you feel about this? This is really, I was surprised because you've shared that you haven't felt super confident about math in the past, but this is a pretty complex topic. You seem to be getting it.
Yeah.
You remember doing this problem?
No.
No, it's okay. Remember this one? You did this one.
Kinda.
Okay. Well, we could do a couple things today. We could go off and practice something else that you know you'd want help with, like percentages or fractions or maybe some geometry things. If you feel like you had a little momentum here and you want to keep digging in on this, this is a skill that'll pop up on a number of questions on the high set.
Yeah.
That's option 2, is we could just repeat this. Or option 3 is I literally have that same packet I sent you on my computer, and you can go through the packet on my computer and pick a problem you want to do. So basically, do you want to do this style of problem again, or do you want to find something new? Okay, all right. Easy. Make my life easy. Monologue for 3 minutes for you to say that. Okay. So we'll do a reminder problem, and how teachers build these problems up will probably help you understand how to then unravel it. Typically we'll go, okay, we have some function y. Let me back that up and make a thinner thing here. Will equal 2 factors. X, how about minus 6? And how about x plus 3? And this is actually going to be your end goal. You're going to see what I'm going to do as a teacher to turn this into a problem. I'm going to FOIL. FOIL was that acronym meaning multiply everything in this first term by everything in the second term. So basically first times first time, or your outsides, your insides, your last, whatever. That acronym's kind of cheesy anyway. X times x is x squared. X times 3. Negative 6 times x. Negative 6x, and then negative 6 plus 3.
Negative 3.
That's negative 6 plus 3. What's negative 6 times 3?
Oh, times. I don't know.
Well, what is 6 times 3? Yeah, 18. So what's negative 6 times 3?
Negative 18.
Negative 18, okay. The next thing I'll do here is I'll combine like terms. So anything that has an x squared in it, and we only have one of them, okay. Anything that has an x in it, so now we get to do 3x minus 6x. So you're up 3 x's, and then you lose 6 of them. Now how many do you have?
3.
You have 3. Do you have a positive, a negative 3x? Okay. And then anything that's just a whole number, just the minus 18. So now I do this. I go, that's not your problem. And I kind of gave you a bunch of hints on where to go from here. But you can pick whatever color you want, and you're basically going to unravel the work I just did to ravel up. I'll have you scoot in just a touch. The microphone, yeah, we're good.
Okay. Jeez. I'm not sure how to do this.
It might help to start with that initial structure, being the 2 sets of parentheses that are multiplied by each other. Nice, and that y should be equal to those 2 sets of parentheses. Exactly.
So x
Mm-hmm.
and then minus 3x and minus 18. And you times them, right?
So if you times them, you would ideally get back to this original problem, because this is like this is the factored version, and then this is the multiplied version or the expanded version. So you should be able to go back and forth between these two. That's fine. This is fresh, and it's been 2 weeks. So if we did times them, for example, if we did x times x, what would we end up? That'd be awesome, right? And then what about x times negative 18?
Negative 18x.
Negative 18x. So we're already kind of below here. Maybe if this was positive 15x, but what's negative 3x times x?
Negative 3x squared.
Yeah, negative 3x squared. So now we're starting to kind of mix the terms in this problem with the terms here. But as a reminder, the two terms that are going to go in these end spots are going to be two numbers that multiply to negative 18. And then those same two numbers are going to add to negative 3. So if you remember, just as a visual reminder, this is kind of what you did last time. You found two numbers that multiplied to 28. But then you had to make sure that those numbers also added to 11. And that's why you picked 4 and 7. Okay, so you can go back and kind of make that same factor tree if you want.
So the negative 18?
You're trying to make negative 18, exactly. Right. And you can just worry about the positive, or you can just worry about the numbers and then the negatives and positives after.
Would it be negative 6 or negative 3? Negative 6.
Yeah, there you go, right? And why did you just make that decision?
Because they add to this. And then... Cool.
Well, you've made the right decision here.
Mm-hmm.
It'll probably help you if you double tap that pencil. And then you're the small eraser, so erase that term. And then erase that term. And then even your pluses and minuses, because you might not have those quite yet. Now double tap to go back to your pen. These are the numbers that are going to go into those two spots. Okay. We're not going to write this all out, but let's just check ourselves quickly. X times x?
X squared.
X squared. Negative 6 times 3?
Negative 3. Or negative 18.
Negative 18. Now 3x minus 6x. I did
negative 3.
I did those 2 and 1. See it, but that always works out because you're always going to end up with some amount of x's and then a different amount of x's. And you're going to add them together, and that's why those two numbers are going to add to the middle number. Okay.
So, do I multiply now?
So you've got your factored form. Now I'm going to ask you. Let me write a word down here to see if it springs your memory. This is what I'm asking you to find. Essentially where y equals 0. They're called the zeros or the solutions, and we'll see it on a graph again. But your goal is to find some x value that you can plug in. There'll actually be 2 of them. That when you do plug that value in, the whole equation equals 0.
So negative 3.
Negative 3 would be one of them.
And 6.
Positive 6 is another, right? So typically you could write, like maybe in this corner, x equals negative 3. And then like x equals positive 6. Cool. Put a box around it because you deserve it. Nice, you got the perfect box. And then really quick, just to see it, so we have x squared minus 3x minus 18. Let's just go ahead and try that. So x squared. And then it was minus 3x minus 18. And where do we cross?
-3 and 6.
There we go, right? Okay, so you solved it algebraically, but graphically you can find the same answers actually quicker. And in fact, you don't even have to find the zeros with the graph. You could find the ones, which are like -3.1 and 6.1. You could find the fours, which is like -3.5. Those aren't really as useful. But you can find the x value at any y value you want. That's the power of a graph. This is like every answer you could ever want in one picture. Okay. Cool. Oops, what I just clicked. All right, shall we try one more while we're speeding here? I'll teach you something new, a little different. But quadratic formula. Does that ring some PTSD in your head?
Yeah.
Okay, it's okay. It's not that hard. It's actually the easier way of doing a problem like this. Let's just do one more while we're at it. And instead of showing you the factors, I'm going to do it. I still can't just like think of one that's factorable always, so I just have to kind of create the factors myself. How about... Yeah, this is good, easy. Well, sometimes the ones that seem easy are the hardest. Okay. There you go.
Oh, jeez.
How many x's is that?
1.
1. Yep, that's fine.
Jeez. I said 4, 3, 1.
Yeah, that makes sense. All right, now we have our two answers, 4 and -3. Let's take this equation. Honestly, you could do either equation because they're exactly equal. Whichever one's easier for you to remember. Let's plug it into the graphing app. So it's x squared plus x minus 12. Let's see what our answers are. 3 and -4. Now let's go back to the good notes. We're close. You got the right numbers.
I just messed it up.
These are the factors you chose. Right? And that's what you plugged in. X times x.
So this has to be negative.
Yeah, there you go. And then, exactly. Because what is 4 minus 3?
1.
1. Positive 1. That's what we're going for, is a positive 1. If that was a negative, then your answer would have been right. But since it's a positive...
So, positive 4, -3.
You wrote the right factors here. Now make sure to write them correctly in your equation here. There you go. Now you're going to do that little flipping motion. Yep, there you go. And then just as a quick reminder, the reason the signs just flip is because we're looking for somewhere where x plus 4 equals 0. So we can't put in a positive 4 because 4 plus 4 is 8. We have to put in the opposite sign of whatever that number is, in this case, -4. So that's why you just look at the number and then take the opposite of it.
Yeah.
because the opposite is what's going to always cancel with the opposite. Too many opposites. And then just for demonstrations purposes, x plus 4 and x minus 3. How did you do that little trick where you just flip to the graphing app? Oh my gosh, all right. I'm learning so much. Watch this. X plus 4, x minus 3. Same equation.
Yeah.
So if you know you want to create a graph that crosses at -4 and 3, you can just do it in this form, and it's like easy as pie, right? Okay. Let's do it for real. There we go. Let's do a special case one, and then we'll do a little Pythagorean theorem as well. Or quadratic formula. Pythagorean theorem is the other one that scares math students. So we have, how about this? Go ahead and tell me where this crosses the x-axis, or where the zeros of that are.
-16 and +16.
That's actually a really good guess. In that, the +16 would be correct if that wasn't there.
So just -16.
Well, -16, let's put it this way. Because this x is squared, if you plugged in a 16 right there, then that would be 16 times 16, which is like 264 or something,
yeah.
256, I forget. It's way bigger than, it would be like 256 minus 16, which is
like
still not 0.
8.
Now you're thinking that's also very close to correct. That would be if this 2 right here was multiplied out front. But it's squared, meaning it's some number times itself equals 16 times itself.
4.
Right? A couple ways you can see that. I mean, you can just plug in a 4. What is 4 squared, or what's 4 times 4?
16.
16. 16 minus 16?
0.
0. Well, so we would find our 0 there. There's an algebraic way to solve this, and we'll work on a little bit of this equation solving, where my goal is to find out what x is. So I want to kind of strip away anything that's not directly attached to this x and bring it to the other side. I know I want my equation to equal 0. Okay, and I don't want this 16 over here, so I can cancel out a 16 by adding 16. That's great. That's what's -16 plus 16?
0.
0. Okay, and then if I do something to one side,
Yeah, do it.
yeah, do it to the other side here. So 0 plus 16
16.
equals x squared. That's 0. So now we see, okay, so 16 equals x squared. And then if you really want to stick to the algebra, how you find just what x is, because that's our end goal. What is x equal to? Well, I just take the square root of both sides. And the square root of x squared is pretty easy. How much have you worked with square roots before?
Not a lot.
Okay, so this is probably a step beyond. This is just for a full view of the algebraic way to solve this. You already got the answer. Square root is just the opposite of squaring. If you have something squared, you're asking that times itself is equal to what? And then when you take the square root of something, you're asking what number times itself equals this inside term. So the thinking just kind of goes backward. It's almost like multiplication versus division, or addition versus subtraction. Squaring versus square rooting. It just kind of undoes the thing you just did.
Yeah.
Moral of the story is it cancels out. The square root of something that's squared is just that something. And then the square root of 16, you already figured it out, didn't you?
4.
It was 4. Plus 4 works. Also, what is -4 times -4?
-16.
That would be -4 times +4. What's a negative times a negative?
Positive.
That's exactly right. And if you want to see that here, this pen's going in the positive direction, yeah?
Yeah.
Okay. And then if I turn it around or make it negative, and then make it go in its backwards direction, so a double negative, which way is it traveling?
Positive.
Positive overall. It's just like doing a 360 on skis, a double negative.
Yeah.
Or more like a 180, switch 180, and now you're going forward again. Moral of the story is plus 4 works, because 4 times 4 is 16. Mm-hmm. Also, minus 4 works, because negative 4 times negative 4 is also 16. And if you want to see what this parabola looks like, go ahead and plug it into GeoGebra. X squared minus 16. There you go. So it was just x squared minus 16, I think. Cool. And then I don't know why our blue graph is still there. I mean our green graph. Okay, it went away. There we go. So where does that cross?
Negative 4 and 4.
Right. It's a parabola. It's either a big smiley or a big frowny. Mm-hmm. So it's definitely going to cross at 2 places. If you're ever doing a problem and your answer is just 1 plus 4, then just think to yourself, okay, am I missing something? Oh, wait, this one's can have a positive or a negative answer because of this. One last way to solve this, I'll just show you really quick. X squared minus 16 is actually to look at it more like this. You're going to use the same exact technique that you were using before.
Yeah.
Okay. What number multiplies to negative 16? What 2 numbers multiply to negative 16, but then add to 0?
4 and 4.
4 and 4, negative 4. Okay, so those 2 numbers multiply to negative 16 and add to 0. Therefore, your factored form is definitely the same thing you've been saying here. Not bad, huh? Cool. Whenever you see a problem of this form, without the middle term, without anything with an x in there, mm-hmm. the answer is just always going to be plus or minus the square root of this number here. Put it into those 2 spots. Okay, so like super quickly, now that you've got that on, let's see how fast you can do this one. See if you can apply the same exact pattern to solve that one.
Oh, no. Oh, wait, yeah.
2 numbers that multiply to 25 and add to 0.
Mm-mm. I don't know.
Let's come back here. In this case, we were looking for 2 numbers that multiplied to negative 16 and added to 0.
10.
There you go. I think you were thinking of 5 squared.
Yeah.
It tripped you up a little.
So then just negative.
Boom. No problem, right? All right, let's do, like, these problems are so fast that I'm just going to make you do one more.
Okay.
Just so it just burned in the memory here.
Wait, is it added or subtracted? Or is it multiplication?
Cool. And just for comprehension's sake, x times x
mm-hmm.
is x squared. 10 times negative 10.
Negative 100.
Negative 100. What's 10 times x?
10x.
And then what's negative 10 times x?
Negative 10x.
So what is negative 10x here multiplied by, or added to positive 10x here?
50. Negative 50. No. 0.
0, right? I asked it in a confusing way, but it's 0, right? You have the same positive amount of x's as you have negative amount. Smash them together, it makes nothing, and that's why there's no middle term here.
Yeah.
Okay. Same thinking as these problems, though. You just have a 0, which makes your life easy.
Yeah.
Okay. Not bad, huh? That's like 8 problems we've done already today. Let's do quadratic formula just as an introduction today, and then next time you're going to see that even though it seems scary at first, it's actually the easiest way to solve these problems. And I'm going to pick one that we've already done just for balance's sake. So x squared plus x minus 12. And I'm going to step through it the first time, so you don't have to just guess at what you're doing. So we have, I'll go to your color. This is, I'll actually pick this to put our formula down. This is the big thing that gives some math students nightmares. X equals negative b plus or minus the square root b squared minus 4ac over 2a. It's pretty ugly, right?
Yeah.
But when you sing it along to the melody of Pop Goes the Weasel, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a little friendlier now, huh?
Yeah.
It's a lot easier to remember. I like literally until I was like 20 and like in college, every time I had to use this, I was singing that in my head as I wrote it down. It's also why we don't teach the alphabet just like A, B, C. There's like a song to it, so it's easy to remember. Anyway, so it's really not that scary. And all these A's and B's and C's mean, it's just the numbers that come in front of these three terms. C being, it's whatever number shows up that's not in X. We call them coefficients. They're the numbers in front of the X's. And this problem is really easy because what's the number in front of X squared?
0.
It's not quite 0. You have 1 X squared, right? You don't have 0 X squareds, but you have 1 X squared. What's the number in front of just X? 1 as well. And then what's the number, what is C? What is this whole term? C is negative 12. You've done most of the work already. Now you take those three values, and everything here is either a symbol or a variable that you're about to plug in for. So really plugging into this isn't terrible. It just starts to tell you your answers right away. So negative b being negative 1 plus or minus
1 squared.
1 squared. So you already got the Pop Goes the Weasel in your head. Minus 4, what's A? 1 times C. Negative 12. That's a little trickier. That's okay. All over 2 times 1. 90% of the problems you'll see, A will be 1. Almost always. If it's not, then factoring becomes really hard because we solved this problem by factoring. Yeah, we solved for the zeros. You can factor a good amount of these types of equations, but for the ones that aren't factorable, like there's no perfect number that multiplies to this and adds to this, then this is just your fallback. This is the answer. This will give you the answer every single time, no matter what. It's a little messier, not quite as fast, but you'll always get the right answers, and we'll see that here once we crunch these numbers. So let's do it. X equals, it's negative 1. Yeah, when I say plus or minus, I'm actually meaning there's going to be 2 answers. One will be a plus, and one will be a minus. What's 1 squared?
2. 1.
1, right? What's 1 times 1? 1. All right, here we go. Negative 4 times 1.
Negative 4.
Yep, and then what's negative 4 times negative 12?
48.
48. And is that going to be a plus or a minus?
Minus. Plus.
How many negatives are we multiplying by here?
Oh, it's plus.
It's a plus in this case, right? We have negative 4 times negative 12. So the number will be whatever 4 times 12 is. And the sign is a double negative, aka a positive. I sometimes even think of these as two negative signs like smashed together and one kind of like tilted or whatever. Or they like ran into each other and each bent into like little L's. Anyway. All right. And that's all over 2a, or just 2 times 1.
Oh, 2.
We good with that? All right. What's 1 plus 49?
You said what's 1 plus 1?
Let me just give you the answer right away.
49.
Okay. What's 1 plus 48? There we go. Negative 1 plus or minus the square root of 49 all over 2. We're actually almost there. We are going to do negative 1 plus this number divided by 2. And then we're going to do a second answer, which is negative 1 minus this number, all divided by 2.
Oh, I remember this.
Do you know what the square root of 49 is?
No idea.
It's whatever number.
7.
7, okay. That's all I had to say. It's whatever number. You're like, oh, it's 7, clearly. All right, so x equals negative 1 plus or minus 7 all over 2, which, like I just said, is actually just 2 equations. It's x equals negative 1 plus 7 over 2, and it's x equals negative 1 minus 7 over 2. When I say plus or minus, I literally mean plus or minus. So let me just do one of these really quick because we just ran out of space, but I've got the magic here. It's going to get that little red box up there too, but that's fine. That works. Okay. So let's start with this one here. What is negative 1 plus 7?
6 divided by 2 is 3.
And then what is negative 1 minus 7?
Negative 6.
That would be negative 7 plus 1. And let me just do this for you really quick. Here's 0, negative 1, negative 2, negative 3, negative 4, negative 7, negative 8. So here's negative 2, negative 4, 6, negative 8, and so on. So we're going to go to negative 1 right here. Now we're going to move back 7. Negative 8, right? Negative minus, when you have a negative and you're minusing something, it's like adding. It's just adding into the negative direction.
Yeah.
All right, so anyway, negative 8 over 2. So what is our other x answer?
Negative 4.
Negative 4. Cool. So x equals negative 4 and x equals 3. Kind of a weird box, but we'll take it. Let's check ourselves.
Did we do it?
Yeah, negative 4 and 3. Negative 4 and 3.
Boom.
Different method. This is like how a computer would solve it, just because it's so straightforward. It works every single time. The only hard part is doing the math correctly. But compared to this involves problem solving.
Yeah.
This involves this piece right here, which is like thinking critically and testing answers and stuff. And this is literally a procedure that you just do it, right? It's just easy. But memorizing the formula often throws students through a loop.
Yeah.
So let me do this for you. I'm going to take...
I remember doing this in summer school and I actually liked doing it with that formula.
Well, there you go. Let's do it again. So we'll copy. Oh, you can change the color. I was going to submit a ticket to them saying, hey, you guys should be able to change the color when you highlight things. I just didn't explore enough. All right. So we'll keep that. Go away. Kind of keep this up in the corner. I don't know why I put it there. Let's give you one more problem. In fact, let's give you another problem we've done, just so we know. Okay, so x squared minus 3x minus 18. X squared minus 3x minus 18. I'll start in black. Y equals x squared our goal is to find the solutions, aka the zeros, aka where does y equals 0. Those are all different terms we use to describe the same thing.
When it turned to a positive, would it still be negative?
A negative would be a positive. Yep.
Negative 3 squared would be negative 6. No, it would be negative 9.
Negative, yes. Here, let me toss one thing out here real quick, just because this is a common mistake here. When you do negative 3 squared would actually be negative 9. However, negative 3, when you put it in for b, kind of goes in parentheses. Which this is actually equal to negative 3 times negative 3.
So negative.
So you get a 9, but it's a negative
Yeah.
times a negative, right?
Yeah.
In this case, your negative is waiting for you to multiply the 3 by itself.
Mm-hmm.
In this case, the negative is going to be multiplied by itself twice. So we can get rid of that. But yeah,
But it is negative 9.
Your answer in this case, we're plugging the negative 3 in for b. So we're doing negative 3 times negative 3.
Oh.
So it would be 9. I have to change it to purple. I stole your color on accident.
Times negative 18.
Yeah, 4 times negative 18. Could try it by hand. You could do 4 times 20.
No, 78.
Very close. 72. You only subtracted 1 2 from it. You actually have to subtract 4 2's from the 80.
So 72.
72. Yep. And just remember, it's negative. You can have the negative there, but if you put this negative there, then you need to make sure to keep this negative on the 72. The moral of the story, what's a negative times a negative?
A positive.
Positive. So that can just be 9 plus 72.
How do you do 81 divided by 2? No, you don't do that. Jeez.
That was weird. I've never seen
Oh boy.
that. I believe in you.
Here we go. Got it back. Oh. So you do 80 divided by 2.
What is that symbol again?
80. Oh,
That's
square
inside
root.
square root, right? It's
So 9.
we're forgetting some information that we had here. Yeah. X is going to be equal to the whole equation.
X equals 3.
3 plus yeah,
minus
exactly.
9.
Yeah, and then just the numbers are over 2, not like the x over here. Exactly, perfect.
And then, don't I do the same? Wait. Oh. So x equals 3 minus 9 over 2.
Mm-hmm.
Do this over here. X equals 3 plus 9 over 2. I forgot what to do now.
Now, this is just throwback to 4th grade math. 3 minus 9 divided by 2.
Three minus 9 is negative 6.
That sounds right to me.
Negative 3.
Yep. If we each have $3 of debt, then collectively we have $6 of debt, which is like the opposite direction of that. Cool. So maybe in this, like, yeah, go in this age, go check your answer if you want, or if you want to write it down. Pretty cool, huh? Cool. Factoring.
Wait, then do I write x equals 6 and x equals negative 3?
Yeah, exactly. Cool.
All over the place.
That's okay. So we have the live, you don't have to just post the picture, we have the live creation of it recorded so you can kind of follow a little easier. But again, factoring and quadratic formula both accomplish the same thing. They help you solve for your zeros or your solutions, right? Factored form, you can write something in factored form if you want without solving for the zeros. But its whole purpose, the reason it's so helpful, is to quickly find the zeros.
Yeah.
Because again, that power of having the factors multiplied by each other, you just need one of them to be 0, and voila, the whole thing smushes. So factored form is helpful if you can get to it, but when you can't get to it, and maybe I'll show you a quick example of when you can't get to it, you just need quadratic formula, which is like the hard-coded process that definitely will work every time.
Yeah.
Sometimes when you can't factor, we won't actually do this problem, but let's say you have a problem that looks like this. Okay, quickly, 2 numbers that multiply to 36.5 and add a negative 14.2.
No idea.
I mean, they don't really. They exist. They're the 2 answers we'll get, but the 2 answers...
7.1.
That's probably a fine guess, right? 7 times 7 is almost 36.
Yeah.
Anyway, it's going to be, our answers are going to be something like 5-ish and 7-ish or in somewhere in between there. But the moral of the story is I could very quickly just do this. And this is where you'll get after you practice this a little more. I'm not going to actually solve the problem out, but show you how fast it can be written. Whip my calculator out, type it in, boom, gets me answers, right? Pythagorean theorem is actually pretty powerful. Okay, all right, we only have 6 minutes left. I don't know if we have to really stress a whole nother problem, but let's maybe look ahead to see what we want to do next time, and I'll make a note. You can just remember it. What was that? Fractions, okay. So here, let's just make a note right here. So we're gonna say fractions, and that involves probably a few things, just the basic form of them. That's like the first thing to practice is what's a fraction. And then using, I call it fractions as division. It's a math way of basically saying, hey, a fraction is just a division problem that hasn't been done yet. Yeah. When I write 1/2, I'm really writing 0.5. I'm just not doing the division yet into decimal form. I'm keeping it as a fraction. And honestly, both of these are widely used. Either 0.5 or 1/2, they mean the same thing. And then the last thing is ratios, which is like, if you drive 60 miles in 1 hour, how fast are you going on average?
No idea.
Hey, 60 miles in 1 hour. We're going
30
miles per hour.
Oh.
Right? So ratios are cool because you actually deal with them all the time, like when you're driving in a car, but you don't even think of this as a ratio or a fraction, but it really is. Its speed is much less measurable than distance and time. Yeah. But distance divided by time gives us speed, which is a ratio, and it's one of the reasons fractions help us. So we'll probably focus here next time, and then slowly build here and here over the following session.
Okay.